Hey guys, it's Kira here, and today I'm going to be talking to Joby of NASA JPL.
What would life on Mars look like? That's something I have to think about as part of my job. When I was very young, I assumed that I wasn't clever enough to be a scientist, so I didn't really think about it as a career. I mean, at some points I wanted to be a policeman, then a firefighter, then I wanted to be a medical doctor. At no point did I ever think that I was going to be a planetary scientist, because again, I don't think I realised that was an option. It was only because I found out about the NASA fellowships by chance, and I was reading through the descriptions, and I was basically thought to myself, that's what I want to do. That sounds amazing. I would love to do that. So I applied. Planetary science can be all sorts of things. It basically means you're studying stuff that isn't like out there, like interstellar stuff like other stars. So it's basically all planets that aren't the Earth. It can include the Moon, Mars, Venus, Mercury, the gas giants, comets, asteroids, exoplanets, exomoons, all of the moons of the gas giants we know. It's basically, it's a very, very broad term, let's just say.
So basically anything that isn't a star in the solar system and isn't Earth, right?
Yes, exactly. It's incredible. It basically touches on every single other science imaginable. Things like the time it takes for a planet to turn, has a big impact on the work that we're interested in. So, for example, Mars, the day on Mars is 39 minutes longer than it is on Earth, and that can have an impact in terms of like the amount of light it receives and how frequently, and that can influence things like the temperature of the atmosphere, the temperature of the surface. It's a whole bunch of different things. And it can even give you an idea of things like, what happened to the planet while it was forming. If it turns at a very different speed to what you would expect, then maybe something happened to it, like another planet collided with it. So I work on an instrument called Sherlock. It's a Raman spectrometer. It's designed to detect organic molecules that could be building blocks of life on Mars. Now, it's one of 3 similar instruments that's going to Mars in 2020. There are 2 on board the Mars 2020 rover. One's called SuperCam and one's called Sherlock. And then on the ExoMars rover that's being launched by the European Space Agency, there's an instrument called the RLS, which is very similar. NASA loves acronyms. I can definitely tell you that one. That one is scanning habitable environments using Raman and luminescence of organic compounds.
How do you remember that?
I have said it a lot in the last year, so I have learnt it. It has a camera built into it. Can you guess what that might be called?
Watson?
Yes. It's called Watson. It's another acronym, but I can't tell you what it's an acronym for. I really love my job. I love coming in every day and getting to work in this lab and figuring things out. You get to study something truly exciting. You're looking at other planets. They are, they say, space is the final frontier, and we're going to, eventually we're going to be visiting these worlds. Perhaps not us or our children, but maybe our children's children will be visiting these worlds and seeing them firsthand. We know so little about them. They're so different to what we see here on Earth. It's so exciting.